Okay guys, so here's part 2 of our 2.9 notes. We're going to continue to write polynomial functions. So here on example 3, and we'll do example 4, we're going to write a cubic function whose graph passes through the following points: 1, 0, 3, 0, negative 2, 0, and 2, 1. Okay, now notice on this one, unlike the last one, they gave us what the leading coefficient was. Here we do not know. So this is actually going to be kind of similar to how we did a little bit with quadratics, or writing it in vertex form, or in those different forms. What we're going to actually do is we'll have to solve for a. So what we're going to do is actually plug in these values into our little formula, and then solve for a to get our final answer here. Okay. Now notice here. We see that these three have 0 for our y. So what do you notice about these 3 points? Well, these are actually our x-intercepts, right? And then 2, 1 is just a point that is on the graph. Okay, that's our x, y. So we're actually going to put this in factored form or intercept form, because since we have our x-intercepts, we can do that. Now, do we really know what our a value is? No, that's actually what we're going to solve. So we're going to take our x-intercepts, and as we kind of did with the when we had our zeros in the last 2 examples, we're going to put it into that factored form. So don't forget, when we do that, we do the opposite of what we see. So I have 1, so that means we're going to do x minus 1. Then I have 3, I'm going to have x minus 3, and then negative 2. So that's actually going to be x plus 2. Okay. Now this doesn't give us too much because we still have really 3 different variables here. So what we're going to do now is take our 2, 1 and plug that into our x and y. So f of x, remember, is the same thing as saying y. So where my f of x is, I'm going to plug in my y, which is 1. Okay, any place I see x, I'm going to plug in 2 there. So I have 2 minus 1, 2 minus 3, and then 2 plus 2. Now we go ahead and evaluate. So we have 1 equals a. Keep these numbers in parentheses, because remember, this is all being multiplied here. So 2 minus 1 is 1, then 2 we get negative 1, and then 2 plus 2 is 4. Okay, then I get 1 equals. So now I go ahead and multiply 4 times negative 1 times 1. That gives me negative 4. I'm going to do negative 4a. Remember, this is being all multiplied, so it's a little bit easier when you're writing this that you put the number in front of that variable, so you know you're multiplying, not adding or subtracting. Now I divide both sides by that negative 4, and so my a value is negative 1/4. Okay. Now here, what we're going to do is, unlike the last 2, we had to write it in standard form. Here, we're just going to write it in actually intercept form. So now that we know our a, I'm going to rewrite this. I have f of x equals negative 1/4. And now I just rewrite all my x-intercepts in that factored form. So x minus 1, x minus 3, and x plus 2. And this will be my final answer. Okay, let's go ahead and go to the next problem. So it's going to be the same thing. We're going to once again write a cubic function whose graph passes through the following points: 5, 0, negative 3, 0, 2, 0, and 4, 3. What I would like you to do is go ahead and pause this video and try this example on your own. Okay, let's see what you got. Okay, so notice here that these 3 points are going to be my x-intercepts, and then 4, 3 is going to be my xy point. Okay, don't forget, we are always trying to solve for a here because they didn't tell us what the leading coefficient is. So I have a. Now remember, when I'm plugging in my x-intercepts in the intercept or factored form, I do the opposite of what I see. So with the 5, I have x minus 5, and then with the negative 3, I have x plus 3, and then with the 2, it's going to be x minus 2. Okay, so now I'm going to plug in my xy, which is 4 and 3, into where I see x and y, into my factored form. So since 3 is y, I have 3 equals a. Any place I see x, I'm going to plug 4 into there, so I have 4 minus 5, 4 plus 3, and 4 minus 2. Okay, so I get negative 1, and then 7, and 2. Okay, now I multiply this. I have 3 equals, so 7 times 2 is 14 times, so I get negative 14a. And I divide both sides by that negative 14, so my a value is negative 3 over 14. Now I go ahead and just plug that back in, and I write my final answer in that factored or intercept form. So I have f of x equals negative 3 over 14, x minus 5, x plus 3, and x minus 2. And this will be my final answer. Okay, guys, so if you have any questions, make sure you contact me and make sure you work on the homework assignment. See you guys later.